All right. So, been there, done that. So, we're going to graph exponential functions, and we're going to do this by making a table, you guys. And y'all, if we're raising something to a power, our numbers get really, really, really big really quick. Because like 2 to the 5th power is 32. And they just keep getting bigger and bigger and bigger. And I'm not graphing no 32, so we're not going to do anything like that. So we're going to keep our numbers really small. So you're going to make a table of values. I have froze y'all, haven't I? So we're going to make a table of values, and we're going to pick our own x's. We're going to pick really small x's that are close to 0, and I would suggest that you pick these 4 every time. -1, 0, 1, and 2. Now we're going to start with exponential growths. You know it's a growth if the number you're raising to the x power is bigger than 1. So if the number you're raising to the x power is bigger than 1, it's a growth. If this number is smaller than 1, if it's a fraction that's smaller than 1, it's a decay. So we'll see some of those in a little bit. So here's our rule, 2 to the x power. And for the first one, we're going to have to remember a little bit of our exponent rules. And then we'll get our y values, and we'll get ordered pairs, and we'll graph them. So I'm going to start with 2 to the -1 power. Now, I know we got a lot of cobwebs in our brain from spring break, but what did we do with negative exponents? Move them to the other part of the fraction. So 2 to the -1 is 1 over 2 to the first power, right? And 2 to the first power is just 2, so that is 1/2. So this is the ordered pair, -1, comma, 1/2. So if you're not completely sure how to do the exponent, your calculator will do that. It'll tell you it's 0.5 if you raise it to the -1/2 power, or the -1 power. And then we plug in 2 to the 0 power. What does anything to the 0 power equal? Not 0. Calculator tell you. That's the easy one you should have memorized. Anything to the 0 power equals 1. Anything to the 0 power equals 1. So this is 0, 1. And then we do 2 to the first power. What's 2 to the first power, y'all? 2. And then we do 2 squared, and 2 squared is 4. The rest of them are really easy. So the first one was the only one that maybe should have gave us a little confusion. So anything to the 0 power equals 1. 1 power is itself, and then you square it. So we're going to graph this function. See what it looks like. Notice that all my y values are positive, aren't they? So I don't have to draw it very much on the bottom 2 quadrants. I go left 1 up 1/2, and 1/2 is halfway between those 2 tick marks. 0, 1 is on my y-axis. Then I go right 1 up 2, and then I go right 2 up 4. Oh, I can't count, can I? So what's happening with this graph? If I did more negative numbers, you're going to see that you're never crossing the y-axis. So this is a curve. It's supposed to be a curve. But that bottom one is never going to cross the y-axis. I have mine touching it, but it's never going to cross it. It's just going to get closer and closer and closer to 0. That is called an asymptote. I know it's a funny word, asymptote. Yeah, you looked up for that one, didn't you? An asymptote is a part of a graph that your graph never touches. It never crosses. Okay? Okay? So you don't touch asymptotes. Okay? You get really close to them, but you never touch them. Don't touch. Okay? So x equals 0 is an asymptote for this graph. Let's talk about domain and range for a little bit. Domain, remember, is all of your x values. Well, your x's go on forever, right? So your x's are all real numbers. Your range never crosses the y-axis or the x-axis, so the y has to be greater than 0. That would be your range. Y is greater than 0. So any questions about that? It's really pretty simple. You plug in your x's, do your exponents, and graph your points. Now let's do number 2. Same kind of concept. It's just after we get our number, after we do our exponent, we have to multiply it times a half. And multiplying times a half is the same thing as dividing by what number? 2. It is. So I would pick the same 4 numbers for my x's. And you make your table. Because if we get them too much far away from 0, they get to be really big on us. What comes first? Exponents or multiplication? That's right. So we do our exponent over here. Make sure our exponent comes first. So let's start with 1/2 times 4 to the negative 1. So first we got to do that exponent. So what do we do with the negative exponent? So that's going to be 1/2 times 1/4, right? What is 1/2 times 1/4? Sorry, that's really little. 1/8. Negative 1/8. Digit toy. I've got some. All right, 4 to the 0 power. So this is 1/2 times 4 to the 0 power. What is 4 to the 0 power? Did you memorize it? What's anything to the 0 power? So what's half times 1? A half. Then we plug in 1 for the exponent. So it's a half times 4 to the 1 power. What's 4 to the first power? What's a half times 4? And last we do a half times 4 squared. Exponent comes first.
16.
So half of
8.
That's right. Half of 16 equals 8. That one is 2. This one's going to be kind of tall. Do we have any negative y values though? No, everything's positive.
We have to graph those. Work them out.
Yeah. Then after you work it out, you graph your points. So I go left 1 up an 8. That's a really tiny amount. And then 0, a half. Then right 1 up 2. And then the right 2 up 8. 2, 3, 4, 5, 6, 7, 8. It's kind of tall. Let me double check my counting. 2, 4, 6, 8. And then draw your graph. It's a curve. Put arrows on it because it goes continuously forever. We never cross our asymptotes. We never touch that asymptote, right? So let's talk domain and range. What are my x's? The x's can be what? All real numbers, right? Because left to right we go forever, but up and down we never get below the y-axis, right? So the y's have to be greater than 0 for the range. All right, this is also an exponential growth. If the number you're raising to an exponent is bigger than 1, it's an exponential growth model. Okay? So I said that because the next problem, we have a number smaller than 1 to the x power, and that is called an exponential decay. So if the number we are raising to the x power is larger than 1, it's a growth. If it's less than 1, it's a decay. So we're going to graph this the same way. We're going to pick our x's. We want to pick small x's. Negative 1, 0, 1, and 2. Some teachers make you pick like 5 x's. I only make you do 4. Because from negative 2, sometimes the more you pick, the bigger they get. And sometimes if that last one is really big, I don't make you graph it. Like if it goes up to like above 10, I don't make you graph it. So 1/2 to the x power. And then we'll have y's. And we'll get our ordered pairs. So first of all, The first one is the most difficult. That negative exponent is the most difficult. So remember, for a fraction, everything gets the exponent, right? So it's 2 to the negative 1, or 1 to the negative 1 and 2 to the negative 1. And what do we do with negative exponents? Right, you move them to the other part of the fraction, so that's going to be 2 over 1, which is what? 2. So that's negative 1, 2. And that's the most difficult one. So then I have 1/2 to the 0 power. What's anything to the 0 power? 1. Calculator. Then I have 1/2 to the first power. What's anything to the first power equal? Itself. So 1/2 to the first power is 1/2. This is 1/1/2. And then I have 1/2 squared. Well, how do I square a half? Yeah, I can multiply 1/2 times 1/2, or I could square the 1 and square the 2, right? 1 squared is, 2 squared is 4. So that's 1/4. So let's graph those points and see what happens. Again, all of my y values are still positive. Left one up 2, 0 up 1, right one up 1/2, right 2 up 1/4, and then make yourself a nice little curve. Now this one's called an exponential decay. Why do you think it's called a decay? Yeah, it's going down from left to right. The other ones were going up from left to right. So this is going down from left to right. And you're always going to go down from left to right if your number to the x power is smaller than a 1. So let's talk about domain and range real quick. What's the domain? What's our x's doing? What can my x's be? Left to right. They can be all real numbers, right? Left to right, it can be anything. What about my y values from a range? Can my y values be negative? No, because we have an asymptote here. So my y's have to be greater than what number? 0. Y's are greater than 0. Look at this one. This one's a little crazy. It's a little crazy. Like your favorite math teacher. They're a little crazy. You never have.
Exponent first.
Exponent first. First I gotta make my table, right? I'm gonna give myself a little space here. So negative 1, 0, 1, and 2. I don't really need that much space between them, but first one I do. So negative 2 times 1/4 to the x power. And I get my y, and then I get my 4. All right, so first I plug in my negative 1 power. So that's negative 2 times 1/4 to the negative 1. So exponent first means I give them both a negative 1 power, which means I'm going to flop it, right? So that's negative 2 times 4 over 1, right? I skipped that and did that in my head. So negative 2 times 4 is 8, correct? Y'all see how I got negative 8? I did a little bit in my head. But again, you can put this in your calculator and it'll do it for you. So then I have negative 2 times 1/2 to the 0, or 4th to the 0 power. What's a 4th to the 0 power? And what is negative 2 times 1? 0, negative 2. And then I have negative 2 times 1/4 to the first power. What's a 4th to the first power? What's a 4th to the first power? 1/4. So negative 2 times 1/4 is negative 2 over 1 times 1/4. Multiply across. I get negative 2 over 4, which reduces to what? Negative 1/2. So negative 2 times 1/4 squared. What's a fourth squared? Square them both. So isn't that 1/16? So negative 2 times 1/16. That's negative 2/16. Whoops, my little thingy's in my way. Negative 2/16 reduces to negative 1/8. So that is negative 2 comma negative 1/8. So then you graph them. But what do you notice about all these y values? They're all negative. Guess what in my equation did that to them?
Got negative on the front end.
Sure enough. That's what made it upside down. So if you have a negative out front, you're going to have a graph going down in the negatives. So left 1 down 8. 3, 4, 5, 6, 7, 8. Left 0 down 2. Right 1. Left 0. Right 1 down negative half. And then right 2 down negative 1/8. This way our graph looks upside down. Y'all tell me domain and range. What's the domain? What are my x's doing?
They're going up.
My x's? They're going both ways, ain't they?
Oh, yeah.
They're going left to right. So that's all real numbers. X's can be anything. What about my y's? What can y's be and what can they not be? They can't go above 0, can they? So what numbers are not above 0? Numbers that
Negative
are
numbers.
less than 0.
Negative.
Right. So my range is y is less than 0. All right. Let me scoot this one down. This is where it gets a little crazy. So you can see the whole thing. That's in the way. Look at this one. Now this one has a few little shifts to it. Okay? So what you want to do to this one first, find my notes. My Jonah liked to help me with my notes last night. That's what my scribbles are for. It's so cute.
Oh.
I know. Perfect angels. So they get to be y'all's age and they'll be corrupted. You are when you want to be. All right. So when I do this one, here's what you're going to do. First, you want to graph the regular one, 4 times 2 to the x. And then I'm going to show you what this does. Okay? So ignore the numbers with the x and the numbers that come after it and just graph the original part without the subtraction and adding on the x and subtraction and adding after it. And then we're going to use that to help us shift our graph. Okay? So, actually all you'll have to do, so here's my little steps. Find x equals 0 and x equals 1 for y equals 4 to the 2x and then shift. So you don't have to find all 4 of them, just do 0 and 1. So we're going to make our life a lot simpler. So if you have pluses and minuses with your exponent and afterwards, just do 0 and 1 and then we're going to shift it. So our math is going to be a lot easier. So 4 times 2 to the 0 power. What's 2 to the 0 power? 1. 4 times 1 is 4. And then 4 times 2 to the first power. What's 2 to the first power? 2. 2 times 4 is 8. So 1 8. So let's graph those two and make our curve. So again, everything's going to be positive. So make sure you're able to go all the way up to 8. So 0 up 4, 1 up 8, 5, 6, 7, 8. And our graph is going to look something like this, and it's going to go down in the asymptotes at 0 again. So I just didn't graph all 4 points this time. I just graphed those 2 points. So if you're going to have to shift it, just graph 4 points, or just graph 2 points out of the 4. Now, your original equation. For your x value, you're going to shift it. Okay? So that -1, you're going to do the opposite. So -1 would be left 1, so you're going to shift to the right 1. Opposite of whatever that sign says. And then you do exactly what that one says for the y. So you're going to go down 1 or down 3. Okay? So whatever is in the exponent, you do the opposite. So -1 would be left 1. We do the opposite, which is right 1. And then whatever the other part is, you do exactly what it means. Let me highlight this one yellow to match, so that way maybe it makes sense. So the exponent tells you what to do with the x, and you do the opposite. The one at the end tells you what to do with the y, and you do exactly what it says. So I'm going to graph the correct answer in blue. So I'm going to go right 1 down 3 with both of these points. So right 1. So stop it. There it goes. I'm going to go right 1 down 3. 1, 2, 3. And then right 1 down 3. 1, 2, 3. And also your asymptote's going to go down 3 as well. So where our asymptote is at 0, our asymptote's going to be at -3. So something like this would be our new one. So you simplify the equation, graph that one, do your shifts, and then it says state the domain and range, where our domain is our x's. It's going to be all real numbers. If you write ARN, I know what you mean, all real numbers. And your range, the y's have to be greater than -3. Y is greater than -3. So all you do on these, simplify your equation by chopping off all your pluses and minuses. Graph that one. Use just 2 points. And then whatever's in the exponent, that's your x value shift. You do the opposite. Whatever's at the end, that's your y value shift. You do exactly what it says. Let's do what? It says y is greater than -3. So your asymptote will move from the y-axis or the x-axis when you do that. On these that you have to do the shifting. So if it don't say minus or plus, you do it like you do your 4 points. But if it does have the minuses and the pluses, then do simplify it and then shift it. Because you got more work to do. Let's do one more of these. So this has got minuses and pluses, so we're just only going to do it for 0 and 1. And we're going to simplify it and take off the pluses and minuses to start with. Or ignore those for a little bit. I don't know why I made that so big. I only need it for 2 numbers. 0 and 1. And I'm going to say 3 and then 1/2 to the x. And I'll save the rest of it to shift later. Okay. So there's y and there's our order there. All right, so the first one's easy because what is 1/2 to the 0 power? So what is 3 times 1? 3. And then I do 3 times 1/2 to the first power. What's 1/2 to the first power? So 3 over 1 times 1 over 2. Isn't that 3 over 2? Which is 1.5. If you want it mixed number. questions there? All right, so we're going to graft it. We're going to graph it and then shift it. Okay? Graph it and then shift it. So graph these points and make your curve. So this one's up at 0, 3, and 1, 1.5. So this one goes down from left to right. Make it a curve. Your asymptote is at x equals 0. Mine's not very perfect. I apologize. All right, let's look at our x shift and our y shift. For our x's, we're going to go, remember you do the opposite of what that says. So plus 1 would be right 1, so we do the opposite, which is what? Left 1. And for the y values, we do exactly what that says, which is what? Down 2. Does that make sense? The exponent tells you what to do with your x's. You do the opposite. The y values, you do exactly what it says at the end. So I'm going to go the left 1 down 2. Left 1 down 2. So there's that new point. Left 1 down 2. Left 1 down 2 is where that one new point is. And the asymptote goes down 2 also. So it's going to be down here at -2. So something like this. And there's my new asymptote. And then all we have to do now is talk about domain and range. What's our domain? What's our x's doing? Same thing we've been doing all day. All real numbers. If you write ARN, I'm good. And what's my range doing? X's have to be what? I mean my y's, sorry. My y's have to be doing what? Range is what? Greater than -2. So our points shift and also our asymptote shift with it. So if our y values go down 2, then our asymptote will go down 2 as well. Does that make sense? Also, this can actually be your range, right? The end number will tell you what your asymptote is, which would be your range, depending on if the graph is above or below that number. That's really the most difficult thing for today. So any questions about that? All right, it'll just take a little practice. So we're going to talk about exponential growth and decay models real quick. So I just got a few more problems. And you don't have to write this whole equation or this whole paragraph, sentence, whatever. It's actually like 2 sentences. But you do need to know the growth model. So that formula that's highlighted, you need to have that written down. And you need to note that that's the exponential growth model. Because we're also going to have a decay model. Okay? So we'll have a growth model and a decay model. So let's just talk about what those variables mean. Your A term is your initial amount. What do you think that means, an initial amount?
How much you start out with?
Initial means beginning, right? Like your initials to your name is what letters your name starts with. Okay? So your initial amount of something is what you have to start with. It's the beginning. Okay? Your R is your percentage, and we convert it to a decimal. And your T is how much time there's been. Okay? You might want a calculator. Might be handy. All right. So, here we go for this problem. You put $250 into a savings account that earns 4% annual interest compounded yearly. If you leave it alone, how much will the investment be worth in 5 years? So I got $250. I'm putting it into a savings account. I'm not going to touch it for 5 years. I'm going to see how much it works, how much it's worth. 4% does not happen these days. My savings account is only drawing like 0.5% right now. It sucks. But there are other things you can do to invest your money. So here's what we're going to do. First, you want to set up your formula. So y is going to equal, what's our initial amount? $250 plus 1 plus, what's our rate? Yeah, make that a decimal would be 0.04. Y'all making a percent a decimal, we move it twice, right? Move the decimal twice. To the t, and how many times are we, 5 years. We're leaving it in there for 5 years. Okay? Y'all, that's supposed to be 1.04. This Isabel did not copy correctly. What's 1 plus 0.04? Not difficult. 1.04 to the 5 power. Now, the most common mistake here is not doing your order of operations. What do we do first? Do we multiply or exponent first? Exponent before you multiply. So first you can type in 1.04 to the 5th power in your calculator. It would help if I put my decimals in. 1.04 raised to the 5th power. What do y'all get? What y'all getting? Give me a few decimals. Nobody did 1.04 to the 5th power. 1.04 to the 5th power?
I got 304.163.
That's not what I got. Right rooftop 5.
1.216.
Okay. I'm going to round it to 1.217. And then I'll multiply that times 250. You just want to keep it stored in your calculator without rounding, just hit times 250. And that's how much? Dollars and cents. What y'all getting?
304.
And then dollars and cents only gets 2 decimal places, right? Yeah, $304.16. So in this savings account, if I started out with $250, in 5 years I'll have $304.16. So I gained $54.16 in 5 years, which is better than it would have got sitting in my dresser drawer or me spending it, right? Which is better than you get in 2018. All right, so that's exponential growth. You need to know that formula, 1 plus r to the t. The decay model, the only thing is different is you're subtracting r. So exponential decay is a times 1 minus r to the t power. So I got a few different kind of questions to ask on these. They give us 2 formulas, and we have to tell them if it's a growth or decay, and what is the percentage of increase or decrease. So let's look at the first one. Y equals 3,000 times 0.985 to the t power. Let's first decide if it's a growth or a decay. How do you know? It's less than 1, right? So if it's less than 1, that means we had to subtract something from 1. Does that make sense? So very good. That's a decay. So if this number is less than 1, it's a decay. If it's more than 1, it's a growth. Does that make sense? So I'm losing something. All right. So it says find the percent of increase or decrease. How do we think we're going to do that? Subtract that number from 1. So 1 minus 0.985. And y'all can participate here. .015. And then we change that to a what? It says find the percent. So we move the decimal twice or multiply it times 100, whichever you prefer. It's a 1.5% decrease. It's decreased because it was a decay. Went down. So to find the percentage of increase or decrease, you would subtract that, find the difference of that number and 1, and then you'll get a decimal, move it twice, and change it to a percent. Or multiply it times 100 and change it to a percent.
What does the decrease and increase mean?
Increase means goes up, decrease means go down.
It goes down 1.5.
So we went down to about 1.5% from where we started. We started with $3,000, so my total would depend on my time. We don't know the time to figure it out, but if we knew the time, we know it'd be less than $3,000 or $3,000, whatever it was to start with. Scientists use these things a lot because, like, things decrease and decay over time. Like if you have a dead body of some animal out in the woods, you know, the mass of that body is going to decrease. The bone density is going to decrease. That's how that's the circle of life, right? Good stuff. Y'all tell me if this second problem is a exponential growth or decay.
Growth.
How do you know it's growth? Because this number is bigger than 1. So how are we going to find the percentage of increase since it's going up? Right, we subtract this number minus 1 because it's backwards. What do we get? 0.25. And do we leave it like that? Which is? Find the percent. Move it twice, 25% increase. That makes sense? All right. Y'all have got a good bit of time to work on this in class. So I'm going to stop my recording for right now. Have a good day.